Okay, let's continue on in this section with talking about angular velocity. Angular velocity is how fast something spins. Okay, there is a relationship, by the way, the symbol that's used for that is often a lowercase omega, so it looks like a W, but it's not really. The relationship between that and linear velocity is that linear velocity is equal to a radius times angular velocity. Let me compare the two for you. If you've ever seen these toys that kids sometimes play on, not toys, but things at a playground that have these bars, and little Junior will stand and hold here and somebody else spin the whole thing around. How fast you're spinning is your angular velocity. But if you're the kid standing in the middle here, it seems like you're moving a lot slower than the kid that's sitting out at the end hanging off the edge. That's because their linear velocity is much higher. So oftentimes you can relate one to the other based on what your radius is and where you show up on that circle. So for example, if I have a tire that has a 30-inch diameter, so I got big old tires, and they are spinning at a rate of 50 RPMs, or revolutions per minute. I may ask you, well, if I put that tire on the ground, what's its linear velocity? How fast is it actually going? So I would have to put this thing, and usually if I want to have linear velocity, I would ask you how fast is it going in miles per hour. This is just a big unit conversion problem. Okay, so I'm going to erase I'm going to erase those numbers and put them in again. So I'd say the velocity in miles per hour is equal to the radius. Now I said it was 30-inch diameter, so it's a 15-inch radius. And the angular velocity, I told you, it was spinning at 50 revolutions per minute. You guys should know from your algebra that doing unit conversions, you have to have the right things on the left with the right things on the right. So if some things are going to cancel, other things are going to be put in. If I want to change inches into miles, I could just go ahead and say 12 inches is 1 foot, and 5,280 feet is 1 mile. Notice inches here and inches there cancels. Feet here and feet there would cancel. Okay, and that would get me just to miles. Changing hours is even easier. Since I'm down here with minutes in the bottom, I'm going to start over here on a new line. I have minutes on the bottom here, so I want to say 60 minutes is 1 hour. So the minutes and the minutes would cancel. But what's curious is we're left with revolutions. Nowhere in this rate do we see revolutions. So we have to figure out how to cancel what's 1 revolution. And the answer is that it's equal to 2 pi radians. And you say, well, now we're just in radians. But again, remember I told you before that radians is the default. Radians kind of comes and goes as you need it. So the revolutions would cancel. So basically I would have a problem that would end up doing 15 times 50 times 60 times 2 pi, all divided by 12 times 5280. And when I do all that work, I end up with 4.462 miles per hour. So that's how you convert from angular velocity to linear velocity.